Okay, the next step, remember we've got the glass loaded and we're ready to inject the part. But let's talk about the upper half of the mold. We've not seen that till now. This is the upper. This will be placed over that dry fiber that we had loaded in the lower half of the mold. Again, what's unusual about this particular mold is the lower half is male. Most commonly, the lower would be a female, but for demonstration, this makes a perfect mold for illustrating and showing the resin flow, which is the part you're looking forward to, I'm sure. But before we get there, because it's traditional RTM light in a sense, and I say that because we've made a transparent or semi-transparent upper. You'll be able to see the resin flowing through. Now, that's not our normal construction standards for a production mold. Normally, we will use a little more durable material, but though we aren't able to see through it. But for this demonstration, and often when you're just starting out, it's certainly a good idea to build the upper mold half out of the materials like we have here that enable you to see the resin flow. It helps ones get their minds wrapped around just what it takes to control that resin. You change that fiber load, and you could see a change in the resin flow path. So what we're going to do now is point out just what is it we've got here. What ports do what? How is the mold configured? So let's look at the top because you won't be able to see this in the inject position. First off, we're injecting through 3/8 or 10 millimeter tubing. We're going to inject into this T and tee off. Now that means then that we have two injection ports. One here, one just like it on the other side. Now these ports are reusable. The thing that we throw away is this disposable polyethylene tubing. Now what happens then is we inject in and it flows into these two ports and it'll circumvent the cavity. We'll show that better on the other side of the mold. But what happens now is by injecting through two, we give it a better chance of going all the way around the tool. Although I will tell you, a mold this size, this geometry, we could inject in the one spot and fill the mold. But for demonstration, make it no chance of any kind of hiccup, let's just go ahead and inject in two places, which we often do on much larger tools. So again, we're going to inject in here. It's going to flow to that side. It's going to flow to this side. And you'll see it circumvents when we turn the mold up or over. You're going to see the channel that we've inherently made into the mold, in the mold construction, that allows that channel to exist. The last place that you'll see resin, or once the mold is filled, as it were, is the vent that's in effect in the center of the mold. So you'll see that we'll inject here, it'll inject to these two ports, it'll go all the way around the outside, and it'll come filling up in a converging path, and we'll witness resin here. There'll be a catch pot to catch it, prevent any resin from getting in the vacuum pump. Now, there we have a vacuum gauge, and here we have a vacuum port. This black area, think of it like a suction cup. We're going to pull full vacuum, 3/8 or 10 millimeter in fitting here. So we'll hook our vacuum pump up to here, and in effect, this surrounding area is going to clamp the mold together, just like a large suction cup. We're going to confirm the amount of vacuum by that gauge in the top corner there, which will be in the flange of the mold. So, Don, if you would, let's flip this over and show them just how is the underside configured. All right. We have this area which circumvents outside the mold cavity. This is that clamping suction cup I described. We facilitate that with a wing seal and then a dynamic seal here. So this area is full vacuum, clamping the mold tight together. Here is a resin channel. Remember we had the two injection ports, one here, one there. So the resin's coming in, but there's a channel all the way around the mold right here that the resin flows into that channel around there and then around here, circumventing the entire cavity. Then the resin will end up in that vent in the center. So now, how do we create these grooves? Let me show you that. When we're building the upper mold half, we offer profiles. Makes it much simpler to get the precise size channel because we want the seal to engage and do its job, so it has to be in the right size groove. Well, we offer profiles, and you find them on the website, easily bought by the foot or by the roll. So when we're building the tool, we'll put that down on the profile wax, the calibration wax. We'll laminate over the top of it because the molds are made out of fiberglass and resin. we'll peel them out. They can be reused. We peel them out, and then in this case, that was the wing seal. So this is a cross-section of the seal that's at the outer edge, what we call the wing seal. So we offer then the seal that goes into the mold. Here we have the resin channel seal, or the primary seal. In this case, it's the dynamic seal. But we obviously need the right size groove, so the seal's got the right tension upon it, it does its job. There again, we have a seal, a dynamic seal profile. That profile is laid on the calibration wax, which another video shows how to build tooling and working with calibration wax. But the point in this case is that's what creates the exact size channel or groove that the seal fits into. And this dark seal here is the dynamic seal. Hollow in the center, can be inflated to actually give it more sealing force. Often, though, we don't. There are times that we need to inflate it, depending upon the geometry and sorts, or if we're changing thickness. But in most cases, we don't inflate it, but it can be inflated. But this is the dynamic seal that fits here. And then we want to create that channel we talked about for the resin flow through. Well, we have the ports. We make all the Teflon line ports and offer those. So we make it a kit, as it were. Or you can come and get everything you need to build the tooling, and it's all modular. Well, part of that modular design with all the ports, the seals and all, is the resin channel profile, so that you create the right size resin channel. Now, there's more than one size channel, but the one that was used here is this half round shape. And when the mold was created, that was sitting on the calibration wax. The upper mold that you see here was laminated over that profile. Then we opened the mold up once we were finished laminating, and we peeled out that profile, giving us the right size groove for the resin channel. So, again, resin comes in on this case, both sides, circumvents through that channel created by the profile, will surround the cavity, and then will converge to that port or the vent in the center. So let's watch that happen. Stand by.